What does your body feel like in zero gravity?
What inspires you to become an astronaut?
What exercise do you do? And do you sweat in space?
Would a yo-yo work in microgravity?
So it works.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready for the event.
Wallops Flight Facility, this is Mission Control Houston. Please call station for a voice check.
Station, this is Wallops Flight Facility with our students from the Virginia Space Coast Scholars, the Virginia Space Flight Academy, local schools districts, and Wallops interns. How do you hear me?
Wallops, we have you loud and clear on the International Space Station.
On your last mission, which was harder, adapting to microgravity when you arrived in space, or adapting to gravity when you returned from space?
That's a good question, and astronauts have effects from both of those occasions, and I can tell you that it was harder for me to adapt to returning to gravity than it was to coming to microgravity. And the challenge is that as the gravity increases, as we get closer and closer to Earth, we start to feel the effects of gravity much more, and it starts to weigh us down, and it becomes very hard to stand. And it takes some time for your muscles to remember how to work against gravity and allow your body to stand up.
I know astronauts try to conserve water as much as possible, but it's inevitable that some of it evaporates. Does the ISS ever get humid?
In actuality, on the space station, we don't really try to conserve water because we reclaim water from our atmosphere. And so all the air that we breathe, all the humidity that we breathe out of our lungs, and the water that we use to bathe or take sponge baths with, all of that water, if it escapes into the atmosphere or attaches itself onto the side of the structure inside the space station, actually gets absorbed back out of the air into our reclaiming system, and we reprocess that and clean it and use it again for drinking water, or what we call potable water. So everything gets reclaimed.
Are you currently using hydroponics or any other methods to grow food or plants on the ISS?
We do grow plants on the ISS. We have two habitats or two facilities that we use to grow plants. We don't specifically use something identical to hydroponics, but we do have limited space for soils and the types of setups that we use on Earth to grow plants. So we have facilities that we can grow, that we've grown lettuce in, grass, we've grown some algae recently, and some small species of weeds. So it's important for us to learn how to grow those things, but hydroponics at the moment, we don't specifically use hydroponics, but we use sort of a modified version of hydroponics. But we do grow vegetables, or we do grow vegetation on the space station, and the idea is that we'll learn how to become better and better at that, so that as we become a spacefaring species, we'll have the capability to generate our own food on orbit.
What routine activity that we take for granted on Earth is significantly more challenging in microgravity?
Great question, and the first thing that comes to my mind is taking a shower. We don't actually take showers in space. It's impossible because we can't contain all that water, and there's no way to get that water to fall onto your body and then rinse off the soap and dirt as it passes over your skin. So we take sponge baths essentially every single day. We take a clean towel and thoroughly wet it so that it has a lot of water on it, and then we run that over our skin and try to rub off the dirt and the soap that's on our skin, and then we take a dry towel and tap the water off so that we can dry our skin, and that's how we take baths and showers. But we can't actually take what you would consider a shower on Earth.
What is the maximum number of times an astronaut can go to space? And how does the astronaut's health and body change after staying on the ISS for a long period of time?
That question has a lot of components to it, and I think you're aware, you've probably studied or learned about the fact that when humans are in space, we see changes in our bodies. And most of what we see or understand right now is related to the changes in our bone density and the structure of our bones and the muscle atrophy that we experience, because in space we don't use our legs, for example, or our large muscles in our legs or even our abdomens. We primarily use our hands and our fingers to move around and do things in space. So we've developed countermeasures to continue to keep our muscles strong. We use something called the we call it ARED, but it's resistive exercise device, advanced resistive exercise device, and that's sort of like a home gym and allows us to exercise every day to keep our muscles strong, and also to do weight-bearing exercises that load up the chassis of your body. In other words, allows your body to continue to send signals to your bones so that they maintain their density and their strength. We also run on a treadmill every day to continue to send those heel strike signals to our nerves so that the nutrients flow into our bones and that they maintain their crystalline structure. Other changes that we see are related to our vision and intracranial pressure. We see changes in the pressure, the fluid pressure in our bodies, and we're developing medications and countermeasures to help counteract those challenges. Most of these things normalize when we return to Earth, but long-term they continue to be challenges. The other issue is radiation exposure. We do have a greater exposure to space radiation here than we do on Earth because we have no atmosphere to protect us. And so some of those standards related to radiation exposure can limit the amount of time or number of times that astronauts can go to space. And those are based on terrestrial standards that we set, for example, for radiation workers or someone that works in a nuclear power plant. And we follow those same guidelines when it comes to space radiation exposure, and that can limit your career in space.
How does microgravity affect your sleep patterns?
Well, sleeping in space can be challenging. One of the issues that I experience personally is that my body in space is always in the same position. So the position that you see me in now, more or less free floating, is the same position that I sleep in. So unlike Earth, when you can go into your bedroom and lay down on the bed and feel relaxed because your muscles are no longer supporting you, and you change the way that your body feels loads. So I don't know about you, but I always feel relaxed when I lay down on my back or my side, put my head on a pillow, and go to sleep. That feels nice. But in space, I feel the same way floating inside my sleep quarters as I do right now. My body is in the exact same position, so it's difficult to ever feel that restful laying down that sets your body into motion to actually fall asleep. So that's a challenge. Fundamentally, space doesn't affect our sleep patterns. We still sleep every evening, or what we call evening up here, and that's, we go by the clock, whatever the clock says. If it's 9:30 or 10 at night, we know that's when it's time to go to bed. We don't have any windows in the vicinity close to our sleep cabins, so we don't see the constant day-night cycles. So that allows us to settle down and put ourselves to sleep. But I can tell you that it is challenging, and for me that's mainly because the body position doesn't change. I'm floating in my sleeping bag just like I'm floating right now, and sometimes it's nice to have that change of orientation that you feel on Earth when you lay down in your bed and put your head on your pillow.
Are you weightless like in space, or are you on the ground like on Earth?
Could you please repeat that question?
When you dream, are you weightless like in space, or are you on the ground like Earth?
Dream, when I dream. So far, all of my dreams have been as if I was on Earth, as if I was in a 1 gravity, a 1G environment. I have not had any space dreams. I have not had any dreams in space that have me in space as well while I'm dreaming.
What do you contribute or hope to contribute to the world through your work?
Well, I think that astronauts all hope to contribute to the existence of the human race. I think fundamentally the basis of what we're doing in space is to try to ensure that the human civilization can continue to live. It's important for us to learn to live and work off of the single planet that we have as our home, because we know, based on the history of not only our planet but other planets and worlds in the solar system and even in the universe, that the universe is very dynamic, and there can be challenges for losing the habitability of the environments you live in. And all we have to do is look back to the time of the dinosaurs to know that a single planet species cannot last forever. And that's what's important for us. That's the root of what we're really doing in space. There are other things that we do that are important to science, scientific understanding, the medical community, and medicines and treatments for illnesses on Earth, also material sciences, agriculture, Earth observations, many things that we do in space that are beneficial to humans, not only learning to live in space, but also to better life on Earth. But I think the root of what we do is to expand and extend the human existence, and that's really what I hope to contribute to our world, is that astronauts that come after us year after year and decade after decade and centuries after century really continue to allow humans to exist as a species.
What is the most overlooked attribute of a good astronaut?
I thought about that question for a little bit, and I think one of the greatest attributes of an astronaut is the ability to follow, to be a good follower. We talk a lot about commanding. I'm currently the commander of the space station, which is a rare privilege for any human being. But one of the things that we learn as we prepare to fly in space is that it's important to listen and follow, to take advantage, not advantage, but rely on the strengths of your team members for the betterment of all of you and for the betterment of the team. And so I think followership is a wonderful trait, and one that's critical for astronauts.
Have you ever had to solve unforeseen problems as a team on board the ISS? And if so, do you have an example?
Yes, we solve problems as teams every single day that we're up here, and some very trivial challenges to some that are greater challenges. And well, one example could be a recent problem that we've had with investigating a water leak on the space station. And we rely on, in that case, rely on the skill and the knowledge of each team member to contribute to understanding the problem and helping mission control to come up with solutions based on our experiences and the things that we see together as a team, not just one individual, but to have those other perspectives. And that relates to what I talked about with followership, is that it's important to work together as a team to solve the challenges. And one of the reasons that we have such a diverse background of astronauts on board the space station is that everybody brings a different piece to the table, a different piece of the puzzle, and we can, using all of those pieces of the puzzle, those individuals can solve not only trivial but also great problems that some of which can be catastrophic if we don't find a solution.
Does being in microgravity affect your cognitive capabilities such as memory and problem solving?
It can, and we've seen astronauts suffer from some of those challenges in the past. We do some testing on orbit to try to monitor our cognitive capabilities and our cognitive baseline based on similar testing that we perform on the ground before we leave. But we do have a phrase that we use, and that's space brain. And I've experienced it. I know other astronauts have experienced it as well. Typically, it's related to high concentrations of CO2. And that happens because the air does not always circulate well on the space station. In fact, air only moves if we have fans that actively blow it around the space station. So if you as an astronaut spend a lot of time in the corner of the space station, breathing in and out, eventually you build up a bubble of CO2 around your head, and that can cause something called space brain, where you start to become forgetful and you start to have some cognitive impairments and not actually understand what it is you're working on. And I can tell you from personal experience, I have on previous occasions, for example, been handed a tool and told to go to a section of the space station and exchange that tool for a similar item but with a different serial number. And so I did that task. I took the tool to that location, found the other object, exchanged the two, and then brought the tool back to the individual that handed it to me, and it turns out that the tool I handed back to them was exactly the same one that they gave to me in the first place. So there was some cognitive impairment there and some loss of understanding of what I was doing in that part of space station that allowed me to make a mistake and take back the exact component that I was handed in the first place. So there are challenges like that occasionally.
Does being in space affect your ability to fight infections or digest food properly?
I think it does to some extent. Most of it is just what we perceive when we ingest food. When you first arrive on the space station, the feeling that you have, the sensation inside your body, is that all of your internal organs have moved up in your body towards your throat. And what that means is when you eat food and try to swallow it, it feels like most of the food is sitting somewhere in your upper chest as opposed to down in your belly or lower in your intestines like it does on Earth. Typically that feeling passes within a month or so, but occasionally, even now, I've been up here for 4.5 months, almost 5 months, I still occasionally have that sensation when I eat food that it feels like it's up in the upper portion of my chest. But the digestive system works the same. What comes in still comes out, and that's fortunate because the last thing you want to do is have digestive problems while you're up here.
How does microgravity affect your hearing?
To my knowledge, microgravity does not affect our hearing. We do frequent hearing assessments, and I've never heard anybody report or heard of any medical journals or papers that have written about hearing loss due to microgravity. As far as I can tell, there are no effects from that.
How has going to space changed your perspective about the world?
I'll let my crewmate Ricky Arnold answer that.
Hello to the Eastern Shore. You guys look beautiful from space. Good to see you. And what was the question?
How has being in space affected your perception of Earth?
Well, I think it reinforces, Drew and I talk about what a special place our home planet is, and how peaceful it looks here from space, and how precious it looks here from space, and wish that it was as peaceful on the ground, and that we all cared for it the way we should. Good to see you.
What do you miss most about Earth when you're on the station, and what do you miss most about the station when you're on Earth?
Exactly that. When I'm in space, I miss Earth because I know that my family and loved ones and friends are all down on that planet. But when I'm on Earth, I miss space because I think about how majestic it is to see the Earth from space, how wonderful it is to float here in zero gravity, just like I am now, and the experiences that we have for science and research and technology. Those are very unique in space, and we're very fortunate to be here. So when we're in space, we miss Earth, everything about Earth, and when we're on Earth, I think we miss everything about being in space.
Thank you very much, Commander Vostel. Wallops is very pleased to have this opportunity. We're going to make certain that we get that resupply up to you this fall, and thank you very much.
Yeah, thanks for your time and your support, and it's always a pleasure to talk to our centers that are supporting our launches and sending us vehicles, especially the fresh food and whatnot that comes up. We really enjoy that. So thanks for all your support and for showing up today, and enjoyed talking to y'all.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from Wallops Flight Facility Station. We are now resuming operational audio communications.